Swayam Prabha. Digital India. Educated India.
So welcome back. So we were discussing a couple of example, the evidence or the signature which we identified from Andaman after 2004 Sumatra Andaman earthquake. So this was the part I was discussing from Car Nicobar, where I showed some photographs, ground photographs, and the reality which we observed after 2004 about the destruction pattern. This were the height of the tsunami. In previous one of the slide in the previous lecture, we saw that there was the inundation was up to 7 meter. That is the height of the tsunami wave was up to 7 meters, and the event was just after the Christmas Eve. So people in the initial when there was a flooding condition, people thought of that it is a local flooding, so they moved to the first floor, but the height was much more above this one, so most of them got killed in this one. Very few were survived, and this was the signature of the return wave, when the water which came and broken the wall here of the houses, and when it returned back, it bent the blades of the fan, similar to what we were talking in terms of the run up. If we see the bent wings, then we can also take that as the height of the tsunami wave. So this was because of the return wave. The water entered much more inland, up to 2 kilometers from the coast, and this was the scenario at the airport of Car Nicobar. And even the very huge oil tanks, very heavy oil tanks, were been lifted and moved inland by the tsunami water. So this also helps us in understanding the water energy condition. This was at Hut Bay. So similar signatures. First wave, the height was around 1.5 meters. Second wave almost like 2 meters. Now coming to the another portion, that is an uplift, what we observed, and the subsidence on the eastern side. So uplift on the east along the west, and this uplift along the eastern side. So this was before and this was after. So this island on the west coast of Andaman got uplifted. So now the water comes up to this during the high tide, and this area remains exposed. Similarly, things were been observed by at Sentinel Island, which is away from the main island towards the subduction zone, and this photographs were been provided to us by Coast Guard. So what we see is that island. This is we took photograph, and this is the signature of the emergence of the land after 2000. Nobody wants to go there because of the tribes. They are trying to, and this photograph was again given to us by the Coast Guard, and they are trying to aim the helicopter. Coming to the Port Blair area. Port Blair area, this area earlier was very much used for the paddy cultivation, but now it sits in water. So in 2004, before that, this area was in demand in terms of the not only for the its fertile region, but also for the housing purposes. But now nobody is interested in buying the house in this area because of the land level change which has occurred after 2004. So this is the scenario. What you can see, the plantation sitting in water. Most of the agricultural field are sitting in water. Even the residential areas, they have been forced to move from this because most of the time this area is underwater. The administration has raised the road heights by almost like 2 meters. This is what was the construction which was been done. immediately after the event, and this is the filling up of the roads. The older road is sitting at the bottom here, and now you have the new roads. Okay. So, and then the event of Palu tsunami in 2018, similar thing happened, but yes, of course, this was a bit like difficult for us to understand, because the displacement took place on a strike slip fault, but then also, and the magnitude was not much high, 7.5, but it resulted into devastating tsunami. So what we learn from this is that even though the magnitude is less, and if the faulting is taking place on the strike slip, we should not underestimate the effect of the tsunami. So the whole Palu city was, of course, there was twofold effect. One was because of the faulting. It was strike slip, but this was on land plus in ocean. And then another one was the effect was of because of the loose soil, or we can say unconsolidated sediments, water saturated. So this resulted into an ideal site to trigger liquefaction. So whole land mass in this area moved into the ocean, and you may find some videos on the social media which talks about that how the whole land mass moved, and you can watch there, but we'll try if we can put, but you can do that on your own. So this was a very devastating event again in the history of Indonesia, that with a magnitude even 7.5, where most of us will not expect a mega tsunami or major tsunami or devastating tsunami, but that happened. Okay. So this was the rupture area, and then it shows the intensity, that how it moved. So most of the huge ground shaking was in this region, and that area got affected because of massive liquefaction as well. So rupture was on land as well as in ocean, and the landslide which was been triggered here was the cause for having an unusual tsunami wave heights. So these are few photographs which talks about the subsidence of the area and the landslide which took place close to the coast. Now coming to the past earthquake signature in the sediments, I will quickly look at, and what we can do is that those who are interested can refer our publications which appeared in different journals, and then try to gather more information for that, because there is a part of a complete huge course or large course where we discuss about more about the deposits, how to identify, and what are all parameters we should consider to say that this is tsunami and differentiate the tsunami from the storm and all that. I am not going to discuss here, but we will just share that what best locations at which we can look at for the preservation or the preserved past tsunami signatures, that I will discuss, and then 1 or 2 slides I will talk about that what we got as a signature of the past land level change in Port Blair area. And then I have couple of slides which I borrowed from Professor Kinji Satake from Earthquake Research Institute, where they have talked about the Jogan earthquake, which was a predecessor of 2011, and they knew that the event which they experienced in 2011 is going to occur. so they very well knew about it. So I'll discuss that. That will be more interesting, and similar type of studies we are also stepping in to do for the Indian side. So this part we discussed that usually what happened before the mega tsunami and or mega earthquake along the subduction zone, that over the time the strain has been developed, and at the time when the strain is released it slips, and then land level change take place as well as the tsunami will be triggered. So as one of the example we talked about from the Chile 1960, that how we identified the ancient tsunami deposits. So this is very much similar to that. So if you are having in soil here or the forest close to the coastal region, and during the subsidence, initially it will of course inundate the area, and then you will have slowly this forest will die off again. And so mostly in such regions what we expect is that we will have the formation of wetlands. So soil covered by it remains inundated, and slowly the mud deposits will take place, and some signatures of this tree trunks, okay, if there is a forest which will be preserved within the sediment cover, and this was very clearly observed from one of the example at Willapa Bay from US, where you can see easily the tree trunks which are sitting dead trees, and this is your modern salt marsh. So we slowly get into the formation of the salt marsh, and this was the another evidence which we discussed in the previous slides, that we are having the land which got subsided, and then we have some preservation of the sand which will be left out, and then we have this one. So one is the evidence of the land level change, and land level change plus the tsunami deposits which we try to identify or locate in sections. And the best locations are for the shallow or the trough regions behind the beach ridge, that is what we call back marsh. So in back marsh areas you will always find that there is the tsunamis will remain preserved. So this was the sequence which I have shown in the previous slide, that that slowly after every event there will be in deposition or the formation of soil or peat, and then you have another tsunami. If at all it comes, then get preserved, and it will create a sort of a sequence which has been seen here. So you have sand soil couplets in the region. So this situation prevailed after the event of 2004 in Car-Nicobar. So you are having this port, this side is the beach area, that is the ocean front, and then you have a beach ridge. So elevation reduces here, and then you have in back marsh. So this is the ideal place for us to look for the previous tsunami deposits. So how to hunt for the past earthquakes? What we did, we carried out some trenching, as I have shown from the Chile area, Maujin, and similar things similar methodology we adopted here in Andaman. So some signatures we gathered from these two locations over here. So one of the location which I am showing is next one is this one. So we found some tree logs, but could be due to the coastal erosion, so we are not very sure about it. This was our first field, but of course what we saw is the older bunkers. This is the Japanese bunkers which are sitting right in waters, but it should not have been sitting here, because bunkers will be always created in the area in the hidden side. So this is one of the signature. Of course, if we look at the close up here, this is what is the raised vegetation level at the time of 2004. So definitely the height over here was up to this one in 2004. You can see this, and the similar signatures we found from the 2011 Tohoku earthquake site also. So this is 2004 tsunami sitting on the soil of 2004 soil, and then tsunami coming in, and then previous tsunami event signatures are over here, which is sitting on the previous soil. So such things which we try to identify and try to date, study in detail the microfossils, okay, and try to differentiate between the storm and the, so because if the water is coming from the deeper side, it will scour or bring the sediments and the forams or microfossils from the bottom area or sea bottom and deposits in such material. So that also helps us in identifying whether it is tsunami or it is related to storm. So this area we visited, again very much similar to the Chilean area. So this people used to use this region for agricultural purposes, and we have taken this photograph from the high ground, but now it remains underwater. So this was the tsunami direction we open up. So whatever the sand you see has been brought by all during the 2004 tsunami, and we also were been able to identify some sand deposit over here, which indicates the paleo tsunami signatures, ancient tsunami signatures. These are the type of trenches and the details which we try to gather when we are hunting for the past signature of the tsunamis and all that. Whereas this one is a clear-cut indication that this area remained in a deeper environment for longer time and then got back to the normal what we see from the comparatively coarser deposits. And very sharp signatures were been identified between the two sediments layer, which also indicate us that this were because of the sudden change in the land level. So next slide, we will be showing that. Okay. So what we did was that we opened up the trench and then we took this section. So these are the tools which we are using is from Japan, and they are they use very commonly, but now we also have similar thing. So what we did was deeper part we found a very thick, this is the what we say the PT unit, and then below peat we are having a very sharp contact and we are having the tidal intertidal sequence. So this sharp contact again suggests that this event or the environment, this environment was suddenly changed, and then you have deposition of this one, so deeper part. So this again indicate us that this area at the time of before the earthquake was under intertidal region, but then went into the deeper environment. So this was a sudden change. Okay. So what we have, fine sand with PT material, so in tidal intertidal area or subtidal area, and then we are getting into the fine sand deposits or very fine silt. And the ages what we have is from like around 1600, and this is older. So what we suggest that around 1600 this event occurred. So this again indicate that this was a big event similar to 2004 itself, but the effect was different in the sense. It was not sourced close to Bandache, but very much in Andaman region. So coming to this part, this is a bit interesting, that gathering all the information, how best we can study, or how best we can try the mitigation plan and reduce the risk. Okay, so I'll come to this one. So this says giant tsunami in Holocene, that is in last 10,000 years geological and historical evidence and geophysical methods. So professor from Kenji Satake, he is one of the pioneer worker on tsunamis, and one of the model which I was showing in my lecture was given by Professor Satake from his lab. Okay, so he that what I was telling, that they knew about that similar like 2011 type earthquake will occur anytime in this region. So this is a slide which shows about the wave height at the time of 2011 Tohoku tsunami in Sendai area. And what they found was this, again they have done after the 2011 event, they have also looked at the similar signatures what we were showing in our slides, that they have looked for the tsunami deposits. So this shows the inundation of the tsunami and deposition of the tsunami. What another interesting thing which they identified, usually what we used to do, and of course they were also doing that, and other paleo tsunami scientists used to do, is that they used to identify that, okay, if until which point in the coastal region this coarser deposits are been seen, okay, and after that we'll say that, okay, fine, this was the inundation limit. But what they found was that even the tsunami, that is 2011, inundated much more inland as compared to that what the coarser deposits were being left out. So even the mud dominated deposits, they were able to find out, which went up to almost like more than 4.5 kilometers, and the coarser deposits, they ended something over here. Okay, so that was not only so they have sand stopped here, and then this was sand dominated, of course, but beyond this, almost like 1.5 kilometer inundation was mud dominated. So again, this has come up as a very important parameter, that not always we should rely that saying that the until where the sand was deposited was the inundation limit, but it probably the mud also can indicate the inundation of by the tsunami. So this is the sequence which they found was, and this was what the earthquake of Jogan 869 was the predecessor of 2011 Tohoku earthquake. So they knew that similar this event was devastating event, and similar devastating event can occur any time. They are well equipped in terms of the ancient literature, and they have the records, but in India we don't have this because of we were been ruled by many invaders, and the records were been destroyed, or no matter, nobody bothered to save or put those historical chronicles in place. So this was one of this is one of the drawback which we have, and these people are having advantage, but of course and they are in the better position to save their people or reduce the risk part. Okay, so the text which has been they have translated here, what it shows about a large earthquake in Mutsu, people panic, stricken by violent trembling, lying on ground, fallen houses, and so on. Okay, and it says that about 1,000 people were been killed. Say this is from about the 869 Jogan earthquake. The record is available with them. So what basically I'll quickly move. I'll not go into the detail of each and every slide, but what they did was they have taken the details. These are all along the coast. They have taken the detail or collected the details of subsurface or near surface stratigraphy. So subsurface sediment succession, and not very deep but shallow, but then they have identified and dated the events. Okay, so what they say is that Jogan tsunami deposit, possible Jogan tsunami deposit. So wherever they are doubtful, they have put the blue dot with the blue, but where they are certain, they have put with the red dot. So they took the transects, and this yellow and whitish part is nothing but the beach rich swell topography. So if you take the cross section across this one, you will be able to see something like this. Okay, so these are all beach ridges. These are beach ridge, and maybe you can say this is a coast, and these are all swell region. So beach ridge swell. So they were able to identify the preserved tsunami deposits in this one. They also tried to model different earthquakes with different fault mechanism, and they have also tried to understand that what will be the effect of different earthquakes which are occurring at different depth, okay, and with the different slip. So that what they have done. Suppose, for example, if you are having this event which ruptures the blue part here, this is what we call, so this you are having the subductions of the overriding plate, and this is the plate which is subducting below. So along that plane, so one is overriding over here and another is subducting like that, okay. So if the updip part of the area ruptures, then the effect will be that this portion on the top of, so suppose I put in cross section here. So you have an overriding plate, and then you are having the area then with the ocean. This is your the subsiding plate. So this portion has been shown over here. So if this breaks, this portion breaks, then the area which is sitting here which will get uplifted, and then the area sitting at the tip, the down tip of the rupture will subside, and that what happened in Andaman also. So depending on which a portion is going to get displaced or the locked portion is going to slip, the effect will be different. Suppose this portion at the deeper part, for example, which has been shown here with the light green, if this ruptures, then this area will get uplifted and the down dip tip of this one will be subsided. So the tip of this one will be uplifted, and similarly for this case also. So this is very simple model which has been created and which helps in understanding that what will be the effect of land level change if different fault portion of the locked fault slips actually. So, and this what they found was that if you carefully look at, then we are having the Jogan tsunami deposits, and then possible tsunami deposits of Jogan. So they have prepared an inundation map which also helps us in understanding that how much area will be affected if such event will take place, okay. So this of course included the portion which got affected in 2011 Tohoku earthquake also. So these are the signature again from this Japan, which shows about the older events and the younger events. So this is 2000. The sand layer is younger, of course, but then the Jogan one. So what this helped, this information helped them was that they wanted to see that, okay, fine, whether they have similar events in the past and what will be the recurrence interval in the future, and of course what 2011 in what way it helped, okay. So B layer is your Jogan layer, and then there is another one over here which is again around 1500 AD or so, and then they had in 2011. So this is Jogan in sand B and sand A. So if you look at that, then what they have is around 1500 or 1400 1500 AD. They had another event after the Jogan 869, and then they had in 2011. So if they believe and what they have based on the signatures, what one can see is that the recurrence interval is almost 580 years between such events. So anyway, thank you so much for being with us in this course. I'll stop here, and I hope you enjoyed, and if you have any questions or any query, do write to us and feel free be in touch with us, okay, and we'll try our best to help you, and whatever we were unable to cover in this course, we'll keep offering different courses, and we'll try to keep you updated with the work which we are doing at IIT Kanpur and with other institutions in India to give you the better environment in terms of the safety from such hazards. Thank you so much. Jai Hind.